21 students were asked if they studied either Mathematics M or Biology B or both. The Venn diagram shows some of the results. One of the 21 students is selected at random. Find the probability that the student studies mathematics but not biology. Find the probability that the student studies both mathematics and biology. Given the student studies only one of the two subjects, find the probability that the student studies mathematics. Given a student studies mathematics, find the probability that the student studies biology. Okay, so here's a Venn diagram. So the probability that the student studies mathematics but not biology, that's represented by this part on the Venn diagram. So in set notation, that is M intersected with not B. So the probability of M intersected with not B will be the 9 in here out of the 21 altogether. 3 goes into 9 3 times and 3 goes into 21 7 times, so cancel down to 3 7s. B, the probability the student studies both mathematics and biology. Well, that's going to be the bit in the middle here. We can find that because we know there's M intersection B, that's 21 minus 9 minus 6 minus 3. So 21 minus 9 minus 6 minus 3 gives me 3. So the probability of M intersecting B, this is the set notation for it, is going to be that bit there. So it's going to be 3 out of the 21. That cancels down to 1 7. 3 goes into 3 once and into 21 7 times. Now, the probability he studies mathematics, given the student studies only one subject. So this is now what we call conditional probability. There's a condition on it. So returning to our Venn diagram, the number of students who study one subject is going to be given by those and those. So that's going to be 9 plus 6, which gives me 15 students. So now the number of probability the student studies mathematics, given the student studies only one subject, is going to be the out of 15, because these are the students that study 15, so there's some sort of condition on the probability. And then study mathematics, given that you study one subject, is going to be 9. That bit there, so it's going to be 9 out of 15, which is going to be 3 out of 5. Right, the probability the student studies biology, given the student studies mathematics. So going to the Venn diagram. So the number of students who study mathematics is going to be represented by the number in M, which is that part of the Venn diagram. So it's going to be 9 plus 3. So that's going to be equal to 12. The probability study is B given M. It's going to be here, because this is the only bits that study M and study biology. So it's going to be 3 out of 9 plus 3, which is 12, which cancels down to a quarter. Now this is gives us rise to the formula for conditional probability. You don't need to know the formula for IGCSE, but it's interesting to look at it. The probability of B given M is going to be equal to the number in B given M, which is the blue bit and the red bit here, the bit in the middle, divided by the number in M, which is all that. Now, more formally, if later you will learn this formula, the probability of B given M, so this symbol here, a straight line, means given, is going to be the probability of B intersection M divided by the probability of M. Now, B intersection M will be 3 out of 21, divided by the probability of M, which is 12 out of 21. If you do that, the 21s will cancel out and you end up with 3 12ths and 1 quarter like before. This is called conditional probability. So this has been a video to show you how to find probabilities from Venn diagrams and a little introduction to what's known as conditional probability. I hope you've understood, and I thank you very much for watching.